Hi everyone. In this video, we will maximize values of a quadratic function. A farmer is building a fence to enclose a rectangular area consisting of two separate regions. The four walls and one additional vertical segment to separate the two regions are made up of fencing. If the farmer has 696 feet of fencing, what are the dimensions of the region which enclose the maximal area? Here we have a picture drawn of what the area is that we're trying to build a fence around for the farmer. And there are two dimensions. We have a length and a width, and we can name them whichever way we want. I'm going to go ahead and I'm going to label this one the length, and I'm going to use cursive because my L's look like ones, and we'll name this one the width. This helps us because we can write a couple of things down about the fencing and the area of this area that we are trying to build a fence around. We know that perimeter will be all of the fencing added together. And because I have 1, 2, 3 widths that I need the fencing to go through, I know the perimeter is going to be 3 of those widths together. And then I have 1, 2 lengths that the fencing will need to take place over as well. So the perimeter is going to be 3 of the widths plus 2 of the lengths. We also know the total amount of fencing that the farmer has, which is 696 feet. So that will be the entire perimeter of the fencing that we will be using. So we have 696 feet equals the 3 widths plus 2 of the lengths together. And we know that we've been asked to maximize the area. So we need something else. Area is found by length times width. And we want to maximize that. But we don't have the length and the width yet. But we do have something that we can help find the length and the width, which is our perimeter equation. We can take this and solve for one of the variables, and it doesn't matter. Any of them work. I will choose the length. So I get 696 equals 3W plus 2L, and subtract 3W so that I can solve for L on both sides. And I get 696 minus 3W equals 2L. Again, I could have solved for W, but I'm just picking L just because. Then divide both sides by 2. And I can break that into 2 equations. So I get 696, not 2 equations, 2 fractions. 696 divided by 2 minus 3 over 2W. And 2 divided by 2 cancels. So this equals L. And 696 divided by 2 is, in my calculator, 348 minus 3 halves W equals the length. Now the important part of that is that I have an L in terms of W so that I can substitute it into my equation or my area formula of length times width. So I have the area equals the length, which we just found, is this entire thing here, 348 minus 3 halves W, and that's L. And now it's being multiplied to the width. And now all of the variables in there are just W. To simplify this, we're going to go ahead and do the distributive property. And W times W is W squared. So I'm going to move that one to be the first term. So we get negative 3 halves W squared. And W times a positive 348 gives us plus 348W. And this equals the area. Now we have an equation that is a quadratic because I have a W squared, I have a B in front of the W. I don't have a C here, but I don't need that to be a quadratic. We could put plus 0 for C, but I'm going to leave it as it is. This quadratic, we see that the A is negative 3 halves. And that's important because I know that it is a parabola. Let's do a quick graph down here. A parabola that has a negative value is one that opens down. And one that opens down has a very top value or a peak value, in this case, a maximum, which is exactly what we're looking for. we were asked to find the maximum area. So now we need to find that vertex of this quadratic equation of -3/2 w squared plus 348w. To find that, we use our shortened condensed version of the quadratic formula, which is x equals -b over 2a. However, in this case, I'm not working with the variable of x, I'm working with the variable of w. So it's w equals -b over 2a. A, B, and C were given to us right here. A, B, C is 0, but we don't need it in this case. B is 348, so we get -348 over 2 times A, which is -3/2. 2 divided by 2 is 1, so that simplifies to -3. And -348 divided by -3, a negative divided by a negative is positive, so we get a positive, in my calculator, 116. And so now we know W equals 116 for our fencing here, equals 116 feet. Now we just need to find the length because we were asked to find the dimensions, but we have an equation for length, and if we have the W, which we just found, we can find the length. So the length equals 348 minus 3/2 times W, which we found is 116. 116 divided by 2 in my calculator is 58. And so we get length equals 348 minus 3 times 58. 3 times 58 in my calculator is 174. So we get 348 minus 174, and 348 minus 174 in my calculator is 174. So the length is 174, and now we have both of our dimensions, 116 feet by 174 feet, and the order doesn't matter. We can put those dimensions however we want to. In fact, let's write it out. 116 feet by 174 feet. And now we're all done.